Alright, today's lab you're going to be looking at the idea of refraction. So just to remind you, refraction is the bending of light. And the reason it's bending is because we're going from one medium to another. So for example, you're going from air to water, or air to oil, air to glass. All those are changing mediums. So we're going to examine what happens to the light as it goes from one medium to another. Now, as we talked about last day, when it does go from one medium to another, it actually is changing speed. And so because it's changing speed, it forces the refracted ray to travel at a different angle. So the way we show that is by taking a line that represents the barrier. Now, on the line, we can look at what's happening above it. So we'll make the green here, that can be air. Below that, we can make it a different color, and this could be glass. Right? But we have two different mediums. And so when that happens, we can then put an instant ray, and what you'll be using is a ray box. So you're going to shine an instant ray onto the barrier. Right? The instant ray then can be marked with an arrow indicating the direction it's going. When it hits the barrier, what will happen is it will change direction. And when it changes direction, then it'll either bend inwards or it'll bend outwards, right? Depending on the medium, which is something that we'll examine a little bit later on. But the main thing here is that this here is your refracted ray. Right? Again, we would draw an arrow indicating that's the direction it's going, and then we are going to measure the angle, and that angle will then help us provide us some information about the medium it's actually traveling through. You'll also observe during your lab that you will get a reflected ray as well, right? But we're not really concerned about this one, right? Again, we're concerned about our incident ray and our refracted ray. So we're going to show a little bit more detail. We're going to name a few parts to this, because as you go through the different diagrams, or when you go through the lab, you're going to have to be able to identify these parts. So again, we're going to draw a barrier. Make sure that's straight there. Alright, so we got our barrier. And then with that barrier, we are going to draw a normal. You'll see that the normal goes on both sides. Right? So we have the normal on one medium, and then we have the normal passing through to the other medium. So it goes straight through, because we need to know where the normal is in relation to our angles on both sides. So again, we don't really need this information here right now. I don't want to confuse you. So I'll just erase that. Alright, so now we're going to draw our incident ray. Our incident ray is going to go right where the normal intersects, because that's where the normal would be created. We're going to put an arrow indicating that's the direction of our incident ray. We know that the angle right here represents the angle of incidence. No different than our plane mirrors. The only thing that's going to change is we're going to refer to that as our angle I. So that's the symbol that we're going to use. That's the angle symbol, and then the little I is representing incident. Now, as it travels through, and we'll just use a different color here, from this point on, it's either going to bend towards the normal, so it's either going to go like this, or it's going to bend away from the normal, again, depending on what's happening to the speed within that medium. So we're just going to draw this as if it's bending towards the normal, and then we're going to name this angle, and then that is your angle of refraction. That's symbolized by an angle symbol and a capital R. So you're going to see both of these. You're going to see angle of incident, you're going to see this in your lab, and you will also see this symbol in your lab. So anytime you see this one here, that's referring to the angle of incidence. That's the angle from the normal to the incident line you created. The angle of reflection is the normal that's in the second medium until the refracted ray. So both of those symbols will be used. Both of those angles you'll have to measure. All right, so those are two important things you have to keep in mind, because we're going to be looking at some ratios and so on using both your angle of incidence and your angle of refraction. The other thing you're going to come across is something that you're not going to be familiar with. It's something that's done in grade 10 math, so I'm just going to give you a quick overview of what it is. And so we're going to draw a triangle. We're going to make this a right angle triangle. So we're going to learn a little bit of what's called trig. Trig is used when you got a right angle triangle, and you're going to be using the idea of what's referred to as sine. Now, sine is a ratio between two sides on a right angle triangle. The angle that we're going to be concerned with is that one in the left corner there. So we're going to go, if we look at this side, that's referred to the opposite side to my angle. So I'm going to go straight across here. The angle in relation to this line, and is your hypotenuse. So when we look at refraction, we are looking at the ratio between our opposite side and our hypotenuse. So the ratio sine equals opposite, OPP, over hypotenuse. I know this probably doesn't mean much to you right now because you haven't taken this in math, but we are going to use this idea. We're going to look at sine, and we're looking at the sine of a specific angle, and that angle is going to be your angle of incident or the angle refraction. So in your calculator, you would look at sine, and just for example, you did 30 degrees. Well, that would give you a decimal answer. That decimal answer is reflecting on or telling you the ratio between your opposite and hypotenuse. So you're going to see this a few times, and so again, in your calculator, you just press the button, that's the sine button, sine function, and you're going to press, if it was 35 degrees, you would type 35 degrees, and then that's going to give you, once again, a specific decimal answer. That is something that you're going to have to calculate in your lab, and it's going to give you those numbers. You're going to actually find these numbers in your lab, and so it's going to look at the sine function. Again, it's a trig function. Again, something that you'll take in math later on, but for the purpose of this lab, all you really need to know is that it is the ratio between your opposite and hypotenuse, you're looking at the ratio between this line here and the hypotenuse of a right angle triangle. To do that, you just press the sign button, type in the angle, it'll give you the decimal answer. And it's that decimal answer that you'll use in your particular lab. Now, for your actual setup, you will use polar paper, just like you did before.